Okay, so for this module we're only going to look at vectors in 2 or 3 dimensions, so we're just going to go over those two cases now. A bit of an introduction in this video, and then we'll look at some problems, and that'll be it. So in 2 dimensions we can consider a vector as, we can describe, say, this point here as a vector by knowing its x and y coordinates. So if its x coordinates A, its y coordinates B, then this point has a position vector AB. Okay, so that's a position vector. Or we can think about it as a direction vector. So we can say, so the position vector is essentially its position compared to the origin, and then the direction vector is to say, well, actually what AB means is that we're going to move A spaces right and B spaces up, no matter where we are in space. Okay, so if we were to add vectors together, we're really looking at direction vectors more, and then if we're just trying to describe a point in space, we're talking about position vectors. These definitions are interchangeable, and the reason is, in terms of conception of things and calculations, the math doesn't care what you're considering it as, so it always works. And then just for your geometrical interpretation of things, you can think of these in a sort of malleable way. Hopefully that makes sense. It wasn't just a load of waffle, but we'll see. Yeah, so in 3 dimensions, I'll give it my best attempt at drawing an x, y and z plane. So x, y and z. It's not z, there you go. So if we have some sort of point in space now with x coordinate A, y coordinate B and z coordinate C, then this point in space from the origin has coordinate A, B, C. Okay, so that's a 3-dimensional case. Nice and simple. There's another form we can write these vectors in if we know some notation. So we've got 3 special type of vectors called basis vectors. You can actually define lots of bases, but essentially, to think about vectors in this ABC type way, well, what does this really mean? Like I said before, it means we go A steps to the right. In the 2-dimensional case, y steps up. Okay, and so on. So what we're saying is we go a certain amount in one direction, a certain amount in another direction, a certain amount in another direction in the 3-dimensional case. So what are these 3 directions? Well, we actually introduce these basis vectors I, j and k. So I is equal to 1, 0, 0, that vector. J is equal to 0, 1, 0. K is equal to 0, 0, 1. So the point of this is, with any combination of I, j and k, you can move anywhere in the plane. Okay, because if you need to go right a little bit, you can use I. If you need to go out a little bit, you can use j. If you need to go up a bit, you can use z. And then anywhere in between, you can use a combination of all those vectors. So the point being, we can write a vector A, B, C, and note that when we can add up vectors in some sort of component-like manner, so A, B, C is equal to A, 0, 0 plus 0, B, 0 plus 0, 0, C. So you can see this now, that we're just adding up all these top columns. That gives us this top column. We add up the middle columns. This gives us the middle column. We add up the bottom. That gives us the bottom one. So that's nice and simple. So we can add up like that. And now another nice thing of vectors, we can take out scalar multiples. So this is equal to A 1, 0, 0 plus B 0, 1, 0 plus C 0, 0, 1. Okay, because A times 1 is A times 0, 0, A times 0, 0, so that's still the same vector. Okay, and of course this is I, this is J, and this is k. So this vector ABC is equal to A multiplied by I plus B multiplied by J plus C multiplied by K. Alright, so that's another form that you might be given in the exam. To me, it's not particularly useful for any of the A-level calculations. It can be useful going down the line, but here you just have to be aware of how to convert towards it. I mean, if you're ever given it in this notation, personally I would immediately convert this into just ABC, like such. For the use of calculation, I think that's easier. But that's my personal opinion. Right, now we're going to talk about when we add vectors, because I just added up some vectors. What does that even mean? Like, well, you know, we've only just introduced this object. Hopefully you've seen it at GCSE a bit. Anyway, but we'll see. So remember we talked about how a vector can be seen to be saying I'm going this much in the x direction and this much in the y direction, okay? And similarly in x, y and z. So if I have a vector that takes me, this vector takes me to the point A, B from the origin, so it takes me A this way and B this way. And then I have a vector here that takes me to C, D. Bear in mind, D is going to be a negative number. If I add up these two vectors, where does that get me? Well, if you think this vector takes me along this line and this vector takes me along this line, so if I add these vectors up, it's like I'm going along this line and then this line, but I'm not going along this line then starting back at the origin and going along here. It's like going up to here and then moving from here along this line. Okay, so all you do is top and tail the vector. So you take this vector and you stick it on the end. You make sure the arrows are still pointing in the correct direction, and this point here is going to be A plus C, B plus D. Okay, so if you wanted to get straight from the origin to this point here, that would be this vector here. Okay, so when we add up vectors, we're adding up size. Okay, so these numbers change, but it also changes the direction of our object, which is a little bit weird. Okay, so that's one example. Now we're going to talk about what subtracting vectors means. Well, and more particularly how we can find the vector between two specific points. So say I don't want to go from the origin to a point A. I have a point AB and I have a point CB, and I want to know how to get from this point here up to this point here. I want to know what that vector is. Well, how do I do that with the information I know? Well, all I know is I know how to get to here, and I know how to get to here. If I've got no other information, I'm going to have to use that. So how can I get from here to here along these paths? Well, I'm going to need this vector, okay, going from here back to the origin, and this one, and I'm going to add them together. And then by adding them together, we've got the same rules here. It would be like going along and then putting ourselves on the end and going up. Well, this vector here is just AB. So this vector, well, it's the same distance as this one here, but we're going in the opposite direction. So all we do is we know this vector is actually minus CB, and then we just add them together. So this vector here is given by A minus C, B minus D. Okay, so hopefully that makes sense. So that's how you find the vector between 2 points. We've also looked at adding vectors. We've looked at the IJK form of a vector. We've looked at the column form of a vector, I guess, and yeah, we just introduced generally what vectors mean in 2-dimensional and 3-dimensional spaces. So hopefully this was a nice little introduction. We'll start to look at some mechanics problems that we can start to solve using vectors, which will justify, retrospectively why we even want to begin with this idea. Okay, thank you very much for watching. I hope to see you in the next one.